Hello, I hope I'm audible. We will be starting with the session now. Dear authors and invited guests, welcome to Technical Session 1A. My name is Dimahi Patel, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, Bangkok, Thailand. The 11th edition of the conference is being organized in a hybrid mode. The physical event will be held tomorrow in Bangkok, and the virtual event is being held through Zoom from 9th to 11th April 2026. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for presentation and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can please write it to me in the chat box. Now, before we start with the session, I would like to introduce you all to the chair we have for the session. We have with us Professor Najira Umpar. Professor Najira is a professor at the National University Philippines with 15 to 25 years of experience in academia. Her work focuses on integration of AI tools such as ChatGPT in education, digital transformation challenges in the Philippine education system, and research on Muslim women's lived experiences. A warm welcome to you, ma'am, and I request you to please share a few words with the presenters today. Hello, Najira ma'am, am I audible to you?
Sorry again. I did not hear what you've said earlier.
Okay, I requested you to please share a few words to the presenters at the as the chair of the session today, ma'am.
Yes. Thank you. All right, so good morning, everyone. It's my honor to welcome you all to this session of the ICTIS conference now on its 11th year. So we are thankful to be part of this gathering of researchers, students, and also professionals in information and communication technology and intelligence system. So I think this conference will give us a good opportunity to share ideas, present research, and of course, to learn from one another across different topics in the field. So to all our fellow researchers who will be presenting, we wish you good luck and a successful presentation. So with that, we look forward to an interesting and productive session. Thank you and welcome to ICTIS. Thank
Thank
you.
you so much. Thank you, ma'am. Now we also have with us Dr. Swapnaja Hirai as our session chair. Dr. Swapnaja is an assistant professor at Pune Institute of Computer Technology. Her research areas include data analytics, smart city technologies, and smart healthcare. She is actively involved in teaching, research, and academic development in emerging computing domains. I welcome you, ma'am. Please share any introductory remark for the presenters today. Swapnaja, ma'am.
Hello.
Hello, good morning, ma'am.
Yeah. Am I audible? Just a minute. Give me a 1 minute.
Sure, ma'am, sure.
Good morning.
Good morning.
Am I visible?
Yes, ma'am.
Yes. Welcome, participant. And I'm very thankful to the organizer for giving me the session chair. My research topic is in the data analytics, machine learning, then deep learning, and other allied subjects. I have total 29 years of the experience, more than 29 years of the experience in teaching, and I'm a PhD scholar from the Geetam University, Visakhapatnam. Thank you. I think this much introduction is enough for participants. Yes, participants. So you can start with your presentation.
Okay, thank you so much, ma'am.
Thank you.
We'll be starting with the presentations now.
Yeah.
First
What's the
up,
time there?
Yes, ma'am.
What's the time there? Here it's at early morning. What's the time there?
Yes, ma'am. I'm from India myself, so it is
So
8
you are
here.
from also India. So
Yes,
anybody
yes.
from attending in person there? Okay, it's all right. Okay. So let us
Yes,
start.
thank you so much, ma'am. Mangavarapu Janvi.
Yes,
Janvi, ma'am, please
yes,
present your study on a
yes, ma'am.
hybrid deep learning and graph-based framework for interpretable Medicare fraud detection.
Yes, ma'am. Good morning to all, ma'am.
Good morning.
It's pleasure to attend the ICTIS Thailand 2026 11th International Conference. Can I share the screen, ma'am?
Yes, ma'am.
Is is my screen is
Yeah,
visible, ma'am?
yeah. Patel, no?
Ma'am?
Is this Patel? Patel, you are.
Ma'am, Janvi is presenting her research
Okay,
paper now.
okay, yeah, yeah.
Ma'am, is my screen is audible, ma'am?
Yes,
Clear.
You are
ma'am. You are
audible.
audible and visible.
Okay, ma'am. I will start my presentation. Ma'am, my name is Jahnavi and my teammates are Bashrun, Himateja and others. We are presenting our title, A Hybrid Deep Learning and Graph-Based Framework for Interpretable Medicaid Fraud Detection, which presents the hybrid framework for Medicaid fraud detection, and it combines the deep learning and graph-based techniques, and it focuses on both accuracy and interpretability, and it aims to detect the complex and hidden fraud detection. And it was developed an academic research project under the guidance of our professor Dr. K. Subbareddy, Department of CS and RGMCET.
Excuse me, ma'am. Sorry to
Ma'am,
interrupt, but we cannot see your presentation screen. We can see your
Yeah,
Zoom screen
can.
right now.
Yes.
okay, ma'am.
Presentation is
Okay,
not
ma'am.
visible. Ah, now,
Okay, ma'am. I will share. I will share. Ma'am, is this
yes.
visible?
Yes,
Yeah, yeah.
yes.
Overview slide
Oh,
is there, no?
yes, ma'am.
Yeah, thank you.
Okay. This is the overview of our paper. And coming to abstract, we proposes a hybrid fraud detection system, it which combines the GNN with XGBoost, and it utilizes the both relation and tabular data, and it detects the complex and coordinated fraud patterns, and it incorporates the explainable AI techniques like SHAP and GNN explainer, and it ensures the scalability and efficiency and transparency. Coming to problem statement, Medicare fraud detection involves complex data relationships, and traditional models fail to capture the entity interactions, and fraud data is highly imbalanced, and it requires the accuracy, interpretable and adaptive solutions. uh, Coming to literature survey, traditional rule based and machine learning models lack accuracy and relational learning. Deep learning improves performance, but it lacks the explainability. Graph based methods capture the relationships, but it miss the deep climb features. This motivated us to develop a hybrid framework. Uh, Coming to challenges, the major challenges, which it includes the highly imbalanced fraud data, and it evolving and coordinated fraud patterns, and lack of relational modeling, and it has the high computational cost and need for explainable predictions. Coming to proposed methodology, first we pre-process the healthcare claim data, and then we construct the graphs representing the provider patient service interactions, and GNN learn the relational patterns, and we integrate these features with claim features, and use the XGBoost for classification, and finally SHOP provides the explainability. Coming to the software architecture, firstly, the input layer receives the Medicare claim data, and it pre processing the handles cleaning, encoding the normalization,
and feature engineering creates the tabular and graph features, and GNN layer extracts the relational patterns. XGBoost performs the fraud classification. Explainability layer, it provides the interpretation. Output includes the prediction and explainable report. Coming to advantages, uh, it firstly detects the coordinated and network based fraud, and it handles the imbalanced healthcare dataset effectively, and it provides the high accuracy and robustness, and it ensures the transparency using the explainable AI, and it's suitable for real world healthcare auditing. Coming to algorithms, uh, CNN, it's used for feature extraction, and transformer for capturing the complex patterns, and GNN for relational learning, XGBoost for efficient classification, SHOP for feature importance and explainable, and GNN for graph level interpretable. And these are the algorithms we used. And coming to summary, hybrid framework improves the fraud detection performance, and it captures the both individual and relational patterns, and it enhances the interpretability using the explainable AI, and it's scalable and adaptable to the real world systems, and it provides the accurate and trustworthy predictions. And these are the references based on research papers that we collect from these references. And thank you for giving me this golden opportunity. Thank you, ma'am. Is
Hello.
there any questions, ma'am?
Yeah. Just a minute. Let me put my earphone so there will not be a noise.
Ma'am, your voice is not audible, ma'am.
Nazira ma'am, any questions for ma'am?
Yeah. Am I audible?
Yes,
Yes,
ma'am.
yes, ma'am.
In the algorithm, you are explain some boosting algorithm.
Yes, ma'am. XGBoost. It's for
XGBoost.
classification, ma'am.
Okay. It's a classification. And can you just compare on the databases how it is working with the XGBoost? Because the database is the graph based.
Yes, ma'am.
So how the data is stored into the graph based?
It's used for classifying the data whether it's the fraud is predicted or not.
No. I want to ask you the way of storing the data into the graph base.
Yes, ma'am. XGBoost is the classification model that works by combining multiple decision trees to make accurate predictions, ma'am. In our project, yes, ma'am. In your
Yes.
project, we use it on the data set where each record represents a claim. XGBoost analyzes the different features like patient details, and it claims the amount, provider behavior, and past history. It works by. Yes,
Just a
ma'am.
minute.
Yes,
Just a
ma'am.
minute. I understood your answer. Very good answer given by you for the exhibits. Now
Yes,
I
ma'am.
shifted my question orientation to the database. Your database is graph based, isn't it?
Yes, ma'am. Yes,
Okay.
ma'am.
So I want to ask you how the values are stored.
How, how the
How the data is stored into the graph base.
yes, ma'am.
How the data is stored in the graph base. Am I
Uh,
audible?
yes, ma'am. You are audible. Oh, 1 minute, ma'am. I'm thinking that. Yes, ma'am. The data is stored in a structured format like rows and columns in a data set. Each row represents one claim, and each column represents features such as.
But it is not a RDBMS. It is a graph based, dear.
Yes, yes, ma'am. It's a graph based. But
So
the
how it
the
can be a structured way?
ma'am that
By the way, which database you are using for experimentation?
ma'am, we are using Andhra Pradesh data set. From Kaggle, ma'am.
Database like Oracle or like that you are using?
Kaggle, ma'am.
Kaggle is the site providing the databases. Free
Yes, ma'am.
data sets. I want to ask the
Data
name
set.
of the database as it is graph based.
Ma'am, we
Like
combined
OJ
both.
or like that, which type of the database you are using? The name
We
of the database.
combine both structured and graph based, ma'am. So it
Uh,
provides the data set, ma'am.
So is it you want to say that XGBoost is using the structured database only?
No, ma'am, it's for classification, ma'am. Data
No,
classification.
it is for the classification, but that classifier is used for the structured or what?
Yes, ma'am. We used XGBoost for tabular data
Okay,
for structured.
okay, fine, dear, and have a good day.
Thank you, ma'am. Thank you.
Yes, thank you, ma'am. Najira, ma'am, any questions for her?
Yes, thank you. All right. So, ma'am, thank you for your presentation. This is actually an interesting study because it actually combines deep learning with graph-based methods. And based on what I have heard, learned about your presentation, it also detects fraud and it focuses on making the results understandable, which is very crucial for healthcare administrators. I have only one question, ma'am. How do you make sure your model is both accurate and easy to understand for non-technical users?
Yes, ma'am. It's a
Yes.
ma'am.
How do you make sure your model is both accurate and easy to understand for non-technical users?
Yes, ma'am. Our model is both accurate and easy to understand. It is accurate because we used advanced models like CNN Transformer and XGBoost, which together learn complex patterns in the data and improve the prediction performance. At the same time, we make it understandable for non-technical users by presenting the results in a simple way, like showing whether a claim is normal or suspicious, along with key reasons such as unusual claim amount or abnormal patterns. So instead of showing technical details, we translate the output into clear insights that anyone can understand, ma'am.
All right. Thank you. So I think that's all for me. And thank you for sharing your work.
Thank
That's
you, ma'am.
all.
Thank you, ma'am.
Yes, thank you, ma'am, for your presentation.
Thank you.
Now, next, I would like to call Asmit Patil to present his study on an adversarial evaluation of stealthy insider attacks and UEBA based defensive detection in enterprise environments. Asmit Patil, are you here with us? I repeat, Asmit sir or any of the co-authors of this paper. All right. Nguyen Tan Min Tam, ma'am, please present your study on beyond accuracy comparison of ResNet 50 and GWN enhanced models for brain tumor MRI classification with Lyme visualization.
Good morning, everyone. Ma'am,
Yes,
can you hear me?
Yeah,
yes,
good
ma'am.
morning.
Okay, so now I will share my screen. You guys, ma'am, can you see my screen?
Yes, yes.
Okay, so good morning, everyone. It's a pleasure to be here at ICTIS conference. My name is Tam, and today I will present our paper titled Beyond Accuracy: Comparison of ResNet 50 and GWN Enhanced Model for Brain Tumor MRI Classification with Line Visualizations. This work is a collaboration between Panglong University, Vic Duc Hospital, and the University of Texas at El Paso. Our central question is very simple. When two models both report 99.9% accuracy, is the accuracy really enough to trust them? So for our motivation, the brain tumor had a 5-year survival rate of only 12% in adults. So that is the reason why early diagnosis is very critical. MRI is the standard imaging tool, but interpretation is difficult and it's highly dependent on clinical experience. In Vietnam, especially, access to specialized radiologists in provincial area is very limited. So AI-based classification can help, but it can only be useful if we can actually trust the model decision, not just its accuracy score. For the problem statement, here is the issue with most existing study. They report a very high accuracy, 97, 98, or maybe even 99% accuracy on all the same Kaggle dataset. But this dataset had a critical flaw. It is not organized at the patient level. So for your information, each MRI scan contained 20 to 26 similar slides. And when slices from the same patient end up in both of the training and the test set, the model will memorize the patient rather than learning the features of the lesion or the tumor. And this is called the slide level data leakage, and it will inflate the performance. So our study directly addresses this. For our contributions, our work make 4 main contributions. So first, we will conduct a controlled comparison between a standard ResNet 50 and a variant enhanced with ghost weight normalization, or we'll call it GWN for shorten. And then second, we analyze how GWN affects training dynamics and coverage stabilities. And third, we apply the line-based explainable AI to visualize where the model are actually looking when they make the predictions. And finally, we'll discuss the impact of dataset splitting strategies and data leakage on the reported result. In this figure, you can see that this is our full pipeline from dataset analysis and pre-processing to slide selections and then data splitting. We use transfer learning with RedNet 50 pre-trained on ImageNet to classify into 3 classes: no tumor, pituitary, and glioma. So for the dataset, I'm so sorry. For the dataset, we use Kaggle brain tumor MRI, and we only selected 3 classes of that is no tumor, glioma, pituitary, and we choose 1,100 images per class. So that will make 3,300 in total. And we will split it into 80% for transit, another 10% for validation, and the final 10% for the test set. So we want to make sure that all of the class are balanced across the subset. And the pre-processing and automation technique, we recited to 224 is 224 pixel in RGB. And we also apply horizontal flipping and 15-degree rotation so that we can improve the generalization and reduce overfitting. For the model architecture, we use the pre-trained RedNet 50 on ImageNet as the backbone, and we also add a custom classification head with dropout and linear. We also tested an improved version with God weight normalization, which is adjust the weight scaling without changing the architecture. The training was done in 2 phases. The first phase, we train the classifier, and then we unfreeze and fine-tuning the entire model. For the first real difference appear in the training curves. RedNet 50 plus GWN converged is just 4 to 5 epoch, and the baseline need 7 to 8. Moreover, the GWN model so much smoother loss curve, which show us the stable validation loss, and the baseline so resistant fluctuations in later epoch. So the optimal stopping point for GWN is around April 10 compared to April 23 for the baseline. So GWN is more efficient and stable. For that is what we can see from the loss curve. So now we're looking at the quantitative metric for both model achieve 99.9% accuracy and 0.99 for macro IUC and the same for F1 score, all across 3 classes. At the first glance, the results look excellent, but as we discussed earlier, they must be interpreted with caution. The dataset does not use patient-wide splitting, meaning slices from the same patient may appear in both of the training and the test set, and this slight level leakage is a cause for inflated performance. And the difference between the two models is only visible at a deeper decimal places. So the GWN do not improve the accuracy, but its benefit lies elsewhere in the training dynamic that we have just discussed. For the Lyme explainabilities, this is the most important finding of our study, and that is the reason why we titled the paper Beyond Accuracy, because when we applied Lyme, the local interpretable model agnostic explanation, to 5 random selected images for each model, Lyme works by generating the sample and identify which image regions is most influenced on the model predictions. And what we found is that both models focus on the background regions rather than the model itself, rather than the tumor itself, because this suggests that the high accuracy may be driven by the background curves more such as the imaging artifacts or the patient-specific scan characteristics or the plant-related patterns, rather than the tumor's features. So there is a difference between the ResNet 50 Lyme prediction versus the ResNet 50 plus GWN predictions, is that the ResNet 50 plus GWN models produce more concentrated and compact activation patterns, while the baseline ResNet 50 show more scattered, diffuse attention. So this indicates that the GWN offers some robustness against the background-driven shortcut learning.
Excuse me, ma'am. This is a gentle reminder that you've crossed your 9 minutes. Please conclude your presentation in the next minute.
Oh, thank you, ma'am. So comparing with the existing study, our RNF50 plus GWN model achieve accuracy and F1 score comparable to the state-of-the-art in this dataset, around 99%. But what distinguishes our work is the methodologies. While previous studies such as Lewis et al. Or Aya et al. Show use the GradCam for visualization, we use another thing is Line for instant level attribution. And also, our model also benefit from 3 design choice, a balanced 3-class setup, and GWN for stabilities. and these factors explain our comparative performance even with a very reduced dataset of 3,300 images. So for our future work, we wanted to build a Vietnamese hospital MRI dataset with patient-wide splitting and single imaging plan. And we also want to hire a radiologist validation for the clinical deployment. And we want to extend with example-based or prototype-based AI for more trustworthy explainabilities. Thank you all for listening. I'm very happy to have your questions.
Swapnaja ma'am, any questions?
Yeah. So in the conclusion, you were saying that bias-aware evaluation. Okay. So can you explain more 1, 2 sentences regarding this particular point? Am I audible?
At which point can you repeat for me, please,
bias
ma'am?
related in the conclusion. Can you go to the conclusion slide? Bias related accuracy, you are saying that, something like that.
Bias. Oh, right. So you are asking about the bias-aware evaluations.
Yeah, bias evaluation. So,
Oh, right. So, why did I make this statement like bias-aware evaluation in our study? It's because normally, we just looking at the accuracy or all the metrics like F1 score or AUC, we are just looking at the number. So, for example, the Chicago dataset, most of the existing study, they are all showing very good numbers of result. Most of them are around 98 or 99% accuracy. So if we only look at the number, the accuracy, we think that, oh, these results are very trustworthy. But as I said, in our study, we use the visualizations like Lime, and we look at it to see if the models is actually learning from the tumor and not the background. And as I showed during my presentation, we can see that the model is not looking at the tumor. It's looking at the background, at something essential to make its predictions. So, which means that we are facing a bias towards this dataset.
thank you very much. Good presentation.
Thank you,
Nazira
ma'am.
ma'am, any questions for her?
Yes, ma'am. Thank you. So first of all, thank you, presenter, for your presentation. What I really like about your work is that you did not only focus on accuracy, but also you included the model interpretability using the LIME or LIME. And yeah, this is very important, especially in medical applications where trust is needed. I have only one question, ma'am. What do you think is the main limitation of your model when applied to real clinical settings?
Thank you for your question, ma'am. So I think that the main limitations of my models when applied to real clinical setting is that our model haven't trained with real data set from real from the hospital for our people. For example, I'm Vietnamese, so I really want to conduct a data set that is based on the Vietnamese biologicals. For example, in this situation is the brain MRI. And another thing is that with the explainable AI method of visualizations like Lime or GradCam, we still need the validation from the doctors. So I think that if we want to bring this kind of work into reality, we also have to test with others type of expandable AI like prototype based or some models that it will explain first and then predict later for more trustworthy.
Yes, thank you. This is actually a strong study. Thank you for sharing your work, ma'am. I think that's all for me.
Thank you, ma'am.
Thank you. Now, next, I would like to call Netika Alagaratharam to present her study on comparative study of LSTM and transformer models for health mention detection on Twitter.
Yeah.
Netika, ma'am?
Yes. Thank you. Okay, I guess I'm audible and also I'm visible, right?
Yes. Please
Okay.
start.
Okay, thank
Yes,
you.
ma'am.
Okay, so good morning, everyone. So this is Nitika Alagaratnam, and I'm from the Department of ICT at the Faculty of Technology, Rajarata University of Sri Lanka. Right. Today, I want to take you into a question that sides at the intersection of artificial intelligence, public health, and honestly, one that feels more urgent every year. So the question is, when someone tweets, I have been running a fever for 3 days, can a machine understand that this person is describing their own health and not just share a story about someone else? So that's the problem we tackled the comparative study of LSTM and transformer models for health mention detection on Twitter. And it's a group one, and with me, Danushka and Vikrama RH is there. So let me start with the problem we are solved, right? So the we are calling it as X has quietly become one of the richest real-time public health datasets in the world. Every single day, millions of people share health experiences on the platform, like symptoms or diagnosis effects or recover stories. This isn't just a noise. This is a kind of a sick, right? If we can extract it reliably, could help us track disease like outbreaks faster than hospitals can report them. But here's a challenge, and worked with the social media text will recognize this immediately. Twitter is as you know, and you have got only 280 character limit, and you have got a slang, sarcasm, and metaphors. Someone tweets that exam gave me a headache. That's not a health mention, right? So, but feeling dizzy again today probably is. Even alone is ambiguous. So we frame this as a binary classification task. So every tweet is either a personal health mention where the author is describing their own health condition or is not. The model's job is to tell the difference between that PHM and non-PHM. Right? So let's move to the literature review that I did. So this problem is a new one. So already researchers have done something on this one. So early system used a kind of a handcraft features, lexicon, syntax rules. They worked on clean data set, but fell apart when language got creative. Jiang showed that the LSTM could outperform traditional classifiers on pharmaceutical tweets, right? Karisani and other person pushed robustness further, like with embeddings. And Gondani used Biobird to hit on F1 score 0.8 on the SMM for H. But here's a gap I found. None of these studies filled, like no one had directly compared LSTM with a full bird and the distilled bird. And here we are going, we like compared LSTM bird and with distilled bird with same data set, same condition and same evaluation. Okay. So before moving sections, I'm going to make sure that like all of you understood what is PHM and non-PHM. a personal health mention should sounds like I have to do a cameo tomorrow, or my little cousin have like a leukemia. This directly describes the health of a specific individual. But if it is a non-personal health mention, it looks like a doing great work to help cancer patients. So health is mentioned, but about a group, not only the author. So the distinction is subtle, and that subtlety is precisely what separates a model that truly understands the language from one that's just pattern matching on keys. Okay, then we can move to the important methodology. Right, so if we are going to consider about our data sets, we compiled roughly around 13K to 13,500 labeled health related tweets. Like it's a consistent with benchmark data set. Each tweet was labeled PHM or non-PHM. We use percentage for training and 20% of data set for the testing. Pre-processing, normal standard pre-processing was happened, like lowercase everything, then strip out usernames, URLs, hashtags, and non-ASCII characters. That means we strip everything that it's going to give a core meaning of the message. And this is important. We deliberately diverge the tokenization strategies based on what each model actually needs. For LLM, we build a custom vocabulary of word index sequences. For Bird, we use their built-in wordpiece tokenizers with maximum of 64 tokens. Right? Okay, so our approach is LSTM, bird, and the tiny bird. So of the LSTM, it's a traditional deep learning baseline. It processes tweet sequentially through an embedding layer, a 64-unit LSTM cell, and two dense layers before reaching the output. It's fast to train, a lightweight, no pre-training required. We added dropout nearly to 0 and 0.2 to try to contain the overfitting. It comes to the bird, it's a bird-based uncased. It's a heavyweight one. It was pre-trained on billions of words and reads every tokens in the context of every other token simultaneously, both left and right. We fine-tuned it for 4 epochs at a level of like a 2E-5 with an Adam W optimizer. So when it comes to the tiny bird, it's a distilled version of bird, 7.5 times smaller and 9.4 times inference. So this is about why we selected these approaches. Then another important thing is the results. So when it comes to the results, this chart tells a story of our entire paper. So if I want to walk it through carefully, look at the LSTM, right? First, this LSTM. So if you only saw that number, you would think that model the perform extraordinary because it's getting an accuracy like 99.56. So it's almost perfect. If you only saw that number, you would think it was an extraordinary, but then look at the test accuracy. It is 81.92, like a drop nearly 80 percentage points. That's not a model that learned the task. That means that the model memorized the training data. When it comes to the we received accuracy like 96.7 and tested at 84.33, the highest test accuracy of all three. And crucially, the gap is only like 20 points. And when we are saying about the tiny bird's training accuracy is 95.52. And the testing accuracy is 84.09. It's a kind of only like 0.24 percentage like below to the full bird. So sorry. So this is the present recall and F1 score for our like all three models. So accuracy alone does not tell the full story. like especially in health applications, like we can't get the final results only based on the accuracy. So that's why we are checking the precision, recall, and F1 score as well. So let's look at the metrics that matters most here. Recall on the PHM class, like class 1, right? This tells all the tweets that actually were like personal health mentions, what
Nita
fractions
ma'am,
more.
sorry for interruption, but you have crossed your 9-minute mark.
Okay. And when it comes to LSTM recall on PHM, it's about 0.67. Bert and Tybert both achieved a recall of 0.88 and 0.85 respectively. Right? So these are the training curves for the Bert, right? So when you see the three training curves of the bird is like quite increasing and quietly decreasing, and the same for the tiny as well. And for the LSTM we found it's overfitting. Like the three reasons like LSTM overfits on the data are specified on words statingly. Tweets are short and like only 280 characters, which gives a recurrent model almost nothing to exploit sequentially. LSTM has no pre-language knowledge, and so it learns from scratch on limited data. And class imbalance causes it over-index majority class patterns. That's why LSTM is fitting. And the final discussion is if our priority is maximum accuracy, and if we have GPU infrastructure, we can deploy the bird. Best test accuracy, best F1, minimal overfitting. That's our high stakes health surveillance system. And if we need to run this on edge hardware or in a mobile clinic in a low environment or in a real time, we can deploy the tiny bird. You like kind of a low less than a quarter of a percentage point of accuracy, and you gain a build that's 7.5 times smaller and 9.54 times faster. So when it comes to the LEM, we are in extreme resource constrained environment where the every tiny birds is too heavy.
Excuse me,
So
ma'am.
under the
Due to time constraint, I please request you to conclude your presentation.
yeah, okay. So the future works we are planning like have more data sets and combining the SEMs and strength, and we are going to collect more data set plus cross-validation tasks for robust and other like transformers we are planning to use. So as we found the bird is the best model for the health surveillance system. And thank you for time, and sorry for like taking more minutes to include my presentations, and I'm happy to take questions from you, panel.
Yes, Swapna ma'am, any questions?
Yeah. Good presentation. I want to ask again, focus on the data set itself, because for the healthcare systems, you have to focus on the data set. I want to ask you one thing. When you are taking the X data method, you said that it is a binary classification you are
Oh,
using. So
oh,
obviously there will be yes and no, and you must be doing NLP, some sort of the NLP there. Okay,
oh,
isn't it?
yeah. Yes,
Okay.
madam.
So I want to ask you, are you considering images from the database and emojis also from the database for the data set?
It
When
was
you are parsing, when you are parsing,
when we are passing the data set, we are using only text. It's a text
only
data set.
only text data set, and
Yes,
on that you are doing the. I have one suggestion. There
huh,
are many AI tools available which will all type of the media data which is there onto the X that can be passed and added, that might have a good type of the classification which will include the sentiments and all these also.
hmm.
Overall, the presentation is very good. Thank you very much.
Thank you so much, madam.
Najira ma'am, any questions?
Yes. Thank you. So first of all, thank you to the presenter for this study. Actually, the topic is very relevant and useful, especially in analyzing health-related information from social media. And I would like to commend you for the clear comparison of LSTM and transformer models, as well your effort in applying them to real Twitter data. So I would like to ask one question, ma'am. What are the main challenges you encountered in detecting health mentions from tweets?
So we collected the data from the Kaggle. So when we are collecting, we didn't get that much of data, right? We collected only kind of 13,000 data. So when we are performing with that data, the model started to like overfit. So at the time, realized like we want more data that can be generalized, not only learn from that scenes data. We need to generalize it. And when we are training that bird and this bird, it took like kind of 7 hours, 7 to 8 hours. So I performed using the collab, and I'm having a GPU, like the limited edition one. So when I'm training it, like got 7 8 hours. So it that was the like a hardship I faced. We faced when we are doing this one.
All right. Thank you so much, ma'am. I think that's all for me. Thank you for sharing your work.
Thank you so much, madam. Thank you.
Yes, thank you, ma'am, for your presentation. Now, next, I would like to call Michael David to present his study on ConfGate XGBoost RF hybrid model for multi-class anomaly classification in 5G-enabled EMTC IoT networks. Sir, you are on mute.
Okay, good morning, everyone. Can you hear me?
Yes, sir.
Okay, and I hope you can see my screen.
Yes, sir.
All right. Thank you very much for the opportunity. I am Michael David from Federal University of Technology, Minna, Nigeria. I'm sharing my work on Confidence Gate XGBoost RF hybrid model for multi-class anomaly classification in 5G enable enhanced machine type communication in IoT networks. This is my presentation outline. The advent of IoT has given birth to the interconnection of billions of devices. The 5G enhanced machine type is characterized with high data rates, ultra low latency, and massive connectivity. As a result of this, we now have severe class imbalance in anomaly detection. Real but critical attacks like SQL injection are often missed by classifiers. Statement of the problem. Network anomaly detection systems struggle with majority benign traffic overshadowing real attacks, high accuracy but pure minority class sensitivity, and therefore there is need for low latency real attack sensitive detection. Our proposed solution, we're making use of a confidence gate hybrid architecture. The first stage, there is a fast XGBoost classifier for initial predictions. And then after that initial prediction, it now goes through the confidence gate random forest low confidence real class samples. The outcome will be a balanced speed and real class sensitivity. This is the methodology. The incoming data serve as input for the IoT. The XGBoost classifier is the first primary model classifier. Then there'll be a confidence check of greater than 0.75, a decision gate. If it is no, it will accept the XGBoost result. If it is yes, it routes to specialist, which is the random forest specialist. At the random forest specialist, there is deeper analysis for real classes. The final output will be a match prediction. The evaluation metrics still under the methodology is accuracy F1 score, MCC, G-mean, and then Cohen's cap. Now for our results, we have both the baseline and the confidence gate. For the baseline's result, accuracy is greater than 99%, but it has poor recall for rear attacks. Examples are the command injection and the SQL injection. Then at the confidence gate, the accuracy is 99.32%. Weighted F1 is 0.9931. The macro F1 is 0.80, which balances across classes. And then the recall improvement is command injection is plus 34.5%. Uploading attack is 31.6, while the XXS is 28.6. For the threshold sensitivity, confidence threshold 0.7 is selected. Actually, the confidence gate is a key parameter in the architecture.
Hello.
Which,
Conference.
hello?
Yes, sir. Please continue.
Okay. The confidence gate theta is a key parameter. Usually it varies between 0.5 to 0.95. The value of 0.75 selected represents an optimal balance between sensitivity and throughput. So this will give out to lower threshold. When there is lower threshold, there will be poor rear class recall. And then with the higher threshold, there is increased latency. Comparison of our result with the state of the art. Against MTL W8 gate, confidence rate recall for command injection is 0.94 versus 0.14, and then it maintains superior precision. For the average inference latency, we have 0.87 millisecond per sample, compatible with 5G EMTC. Our contributions, we're able to define hierarchical taxonomy for 5G IoT net attacks. We've been able to introduce confidence-gated hybrid detection framework, and this is validated on CIC IoT 2023 dataset with superior real class detection. In conclusion, confidence gate improves real class detection without sacrificing speed. Recall gains for critical attacks, command injections, SQL, and injection. And then sub-millisecond latency, practical for 5G enhanced machine type communication networks, which supports actionable threat intelligence. For future works, we hope to validate on physical edge hardware, which will give back to energy consumption analysis, and then explore adaptive thresholding for evolving zero-day attacks. Thank you very much for listening. Be happy to take your questions now.
Swapnaja ma'am, any questions for sir?
Yes, ma'am. Yes, ma'am. So can you go to the conclusion slide, please?
Okay, thank you. Conclusion slide.
Yeah. So recall gains for the critical attacks. So here you are talking about something about the SQL engine. What type of the data set you are using?
The data set we use is CIC IoT. Look at it. That it's on the contribution slide. It's that
IoT data.
Yes, the data is CIC IoT 2023 data set.
Okay. So which sensors you are using for the IoT data for the world experimentation?
Sorry?
Which sensors you are using for the IoT data? Use case I want to ask you about the IoT.
Okay, the sensors that we use for the IoT sensors.
What type of the data it is getting? Which type of the sensors it is? Which type means not talking about the hardware. It is a temperature sensor, or what type of the healthcare sensors you are using there?
Not really healthcare. Okay, permit me to bring in my co-author. Chekwas, please, can you address the question raised?
So collection of the data sets I want to address it from the IoT. Which type
All right.
of the
Hello, Chekwas.
Sir, I can hear you, sir. So
Please.
this, let me come in, ma'am. So the IoT is a Canadian institute.
Okay. Okay. So it is body sensors you are using?
No, this is a home automated network, home security automated network. So where we have the smart cameras, the doorbells, your smart televisions, it has a smart
Okay,
home network.
doorbells and all these things. So it's a more about the
Yes,
environmental type of the thing.
yes. So we
Okay.
have smart
Yeah.
cameras, the
So
doorbells.
so
Yes,
you have a multimodal database?
yes.
Yeah. So you are using the different how the data will be stored as a key value?
Now, these IoT based data sets, they are highly imbalanced because of
Yeah.
the
Yeah.
level of traffic which flows through them. With the help of 5G, now we have multi devices generating data. Now we are having issues of high imbalance data sets, and some of these data are low, while others are more. Now we are solving this issue using a confidence gate model where we are using two classifiers, the XG boost and the random forest. Where XG boost fails, random forest will pick it up. So most other authors use only one classifier, but we were using two to make sure that all classes are captured.
There is one more question I have. As you are using the IoT, uh, how the and you are talking about the all the algorithms at the cloud only. Okay, I want to ask you when the middleware, when the data is transferred on the edges, what type of the algorithm are you working with? Any type of the algorithm on the edges?
Sarah, I didn't get a question, ma'am.
Yeah.
I didn't get a question. Can you come again, please?
Yes.
Come again, please. I didn't get your question.
Yeah. Okay. So any special techniques you are using? Because why I am asking, I have to use for the IoT data on the edges.
On edges, that's
Yeah.
this an edge. It's an edge. Um,
Huh.
is an edge solution for IoT 5G because 5G is an edge network.
Yeah. 5G is your edge network, but are you doing
Yes.
any pre-processing on the edges?
Yes, of course, we did. We have to pre-process the data set.
So any
We
special?
pre-process the data set.
Mm.
Yes,
Yeah. Okay. Thank you very much. Thank you. Very nice and very in line with my research work, what is going on. Thank you very much.
it's okay, ma.
Thank you very much.
Thank you, ma.
Nazira ma'am, any questions?
Yes, ma'am. Thank you. First of all, thank you so much, sir, for your presentation. I truly appreciate the effort in presenting this important study on IoT security and 5G enabled systems. I have one question. What are the limitations of your proposed approach in large-scale 5G IoT deployment?
Okay, so talking about 5G deployment in a large scale. Now, the limitations of this work, we are having issues of hello, can you hear me?
Mm, yes.
Hello?
Yeah, I can hear you.
All right. So now one of the limitations we encountered, we're having issue of massive IoT complexity. Now, in large scale deployment, we have multiple devices, IoT devices, which 5G supports. Now, because of this issue of device compatibility, so because of this massive deployment, issue of massive IoT compatibility will come in because of this complex architecture. Some we have an issue more of, let me put it this way, we have an issue of interoperability.
Mm.
So, and then another issue is issue of latency trade-offs.
Yes. Is that all? Sir, is that all?
Yes, that's for the deployments which we are working on. So these are the foreseen things that we will have issue of interoperability because of the massive supports from 5G and issue of latency trade-off. So these are the two key limitations that we are looking at during deployment in a large-scale deployment scenario.
Yes. Thank you. Thank you. So I think that's all. Thank you so much.
Thank you.
Yes, thank you so much, sir.
Thank you.
Now, next, I would like to call Vinod Maniat to present his study on DCS, a sharp enhanced containment framework for stealthy rogue nodes in software defined networks.
Okay, good morning. Thank you, madam. And so, if you if you allow me to share, I
Yes, sir.
can. Okay, so good morning, all of you. My research is on sharp enhanced containment framework for dynamic threat mitigation, authored by me, Vinod Bimaniad, and my supervisor, Arun Kumar Biar, and my friend Shreyas. Okay. Okay, let see the anatomy first so that we can understand the problem. Actually we have the problem. Uh, we have the problem in the contextual neural network. The shell mimicry. Okay, it will mimic the activities of a good node. The shell mimicry, we call it as the shell mimicry, replicates legitimate network flow pattern to seamlessly bypass a strategic signature detection. So core disruption, the progressively deteriorates a service takes over network flow and taint the underlying topology. So the problem here is the blind spot in traditional IDS. Legacy system lack contextual awareness. They suffer from temporal drift, topological ambiguity, and interpretability blind spots, allowing silence disruption to supersede over noisy attacks. So paradigm shift to network defense. In traditional IDS, a static signature driven, okay, threat assumption usually in signature driven and static. It is static, there is no change. The DCS framework will mitigate that one, adapt conceptual drift and adversarial evolution. It will make the changes and so that it can detect. Interpretability, black box decision making. Okay, it is we don't know what kind of problem will come and why this problem, why this decision is taken. But by using a sharp guided explanation risk attribution, we can easily find out what for it is detected as a particular node as harmful. Response mechanism, rigid binary blocking. Here there is only two decision, binary yes or no type condition, drop or allow. So it will makes a lot of loss time consumption. So sensitive multi-strategy mitigation, example deception sink. Okay, here context sensitive. If it is context sensitive, its score increases. Is in the threshold more than then only it will take the decision. It will not have the binary decision. The operational impact, high false positive rates in the severe service disruption, especially like banking system and other systems. It is very problematic when we use such a kind of things. So that can be overcome by minimal service degradation with a 3.1% false positive rate. Moving from trivial and error back box mathematically modeled context sensitive defense ecosystem. So here the cascading detection is a two-stage pipeline. It fixes in the first 5 seconds flow window protocol entropy dynamic topology will be detected. Okay, it will find out the flow window, what exactly the future engineering, sharp based DCS calculation, anomaly detection, and DCS velocity computation will be carried out in first stage. Its output will be the real-time threat assessment complaints with SDN constraints. So mitigation decision and strategy evaluation, simulation analysis, performance assessment. So dynamic trigger, if DCS score is more than threshold, it will activate the decision. So constructing the dynamic containment score, actually we used a graph theoretic centrality, protocol layer entropy, and temporal volatility. Okay, these are the main components we use to extract the information from the network. Min-max normalization filter FK is used for classification when weight, sharp weight is appropriate or threshold. It will calculate a summation of that and it will provide DCS score. The DCS is mathematically modeled convex combination of normalized behavioral features. It precisely qualifies the disruptive potential of any single node within the network topology. So explainable risk attribution via SHARP. Okay, it will balances between protocol entropy, flow burst, pocket drop anomalies, and betweenness centrality. A containment threshold will be calculated based on this. So game theoretic validation, a feature weight are derived from the Shapley additive explanation measuring exact influence on disruption rather than relying on trial and error. Robust scalability, interpretable range, IQR, based scalable ensures a stable attribution even under noisy network observations, allowing operators to trust automate containment decision. So strategy optimization engine. So strategy efficiency increases, deployment cost will decreases. Risk aversion hyperparameter is considered. The optimal containment strategy is chosen by maximizing the efficiency while actively minimizing the computational cost and collateral damage to legitimate traffic. Context awareness, strategy efficiency is adaptively scaled based on the observed false positive rates and stochastic detection uncertainty. Epsilon is far less than 1. So multi-strategy containment arsenal. So we are considered S1 as a flow dropping, S2 as a quarantine, S3 as a rate throttling, S4 as a honeypot redirection, and deception sync. Okay, these are the problems we tested and we found the result as such. The flow dropping high success but introduces a potential collateral risk to legitimate traffic. Or quarantine, total isolation causes severe service degradation. Rate throttle reduces the flow bursting with moderate operational efficiency. Low collateral risk but suffers from high containment latency when honeypot redirection. Deception sync redirects attackers towards synthetic vulnerabilities, provide the optimal balance of low collateral risk and high efficiency. So hardware in the loop, validation, architecture, uh, controllers, production grade owners, and RYU SDN controls. Okay, these controls are used for test bed. This is the test bed where we can test this kind of systems. And
Hello,
edge.
sir. Sorry for interruption, but you've crossed your 9-minute mark. Please
Uh,
conclude your presentation.
Okay, okay. Edge hardware Raspberry Pi and 4B clusters for IoT hardware in the loop validation. Adversarial traffic created adversarial traffic, SCAPI crafted protocol and spooling. So validation data sets are CI/CID 2018 to CI/CI IoT to T20. It is a very good and CAIDA background. These are the very good data sets used for cyber security. Okay, our performance, when we come to the performance, we got 96.8 detection accuracy of 90 F1 score as 948, 0.948, AC as 0.982 in 2018, CICIDS 2018 data set. So false positive rate is 3.1%, disruption legitimate network flow. 91%, 91.2%, zero shot cross domain transfer accuracy, resilient to concept drift. So this is how the closed loop defense ecosystem work. Okay, row action, next detect, attribution, action, and adaptation. Okay, so this is the process in DCS framework we have. The operational viability at the edge, real-time feasibility, compute time strictly enforced at T compute is less than 0.3 T window. Parallelized extraction guarantees total SDN control compliances. Energy efficiency operates seamlessly on edge hardware. Raspberry Pi clusters require under 2 watt per decision cycle. The future 5G and IoT ready integration into the large scale federated SDN cluster, hashing multiple model telemetry to secure programmable infrastructure.
Excuse
Okay.
me, sir. Please conclude
Okay.
the presentation.
It is okay. This is end of my presentation. I welcome the questions.
Yes, so this is a bit different type of the presentation, but it's very nice actually. Uh, I have one question that you have used for the statistical testing, t-test model, isn't
Hmm.
it? Okay.
Yes,
So
ma'am.
can you bit elaborate on that t-test, how you carried out on the packets or like that to get all the flow, flow dropping and
I'm not hearing properly, ma'am. Some problem is there. I didn't heard questions properly.
Sapnaja ma'am, your voice is not audible to us.
hello.
No, ma'am,
I
your voice is
audible?
glitching a lot, ma'am.
Yeah, yeah. Now I will repeat it again. Can you explain me the t-test? Yeah, yeah. So can
Yeah,
you
yeah, I understand,
explain
man.
the
T-test. Okay, regarding
t-test?
T-test,
Okay.
uh,
What you
T-test
have
are used to evaluate the performance of the proposed dynamic containment score, madam. Framework against several rigorous baseline random forest features, importance of RF and FI equal weight DCS, graph convolution network GCN, and proximal policy optimization agent, static rule engine. For this calculation, we used ensuring static rigorous. The tests are employed alongside the statistical measures such. 'Coherence effect size analysis Benjamin Hochberg false discovery rate and correction. Hello.
Najira ma'am, by then, can you please ask him any questions?
Yes, ma'am. Thank you. All right. So first of all, congratulations, sir, for your presentation.
Thank you.
Yeah, this is a very interesting and relevant study, especially with the growing importance of securing software-defined network against the stealthy and intelligent attack. I have one question. How does your model handle false positives, especially in cases where legitimate nodes behave unusually?
It will generate a 5 second window, madam. 5 second window, it will scan all the usable information, and that information will be calculated by using XBoost model. So XBoost model will give specifically the calculation for threshold. Explainable AI will use it for that calculation weight variation, and it will be calculated based on that threshold. We will decide whether we need to block or not.
Yes. All right. Thank you so much, sir, for your answer. So I think that's all for me. Thank you, ma'am.
Thank you, madam. Thank you very much, giving opportunity to speak here, and thank you.
Yes, thank you so much.
In between, the connection problem is there. Now, am I audible?
Yeah, sure,
Yes,
ma'am.
ma'am.
Okay, thank you.
Yes, thank you, sir, for your presentation.
Okay, thank you.
Now, next, I would like to call Saurabh Nimche to present his study on detect insider threats from employee communications using NLP.
Yes, ma'am. Thank you, ma'am.
Total 10 jana present.
Hope so my screen is visible, ma'am.
Yes, sir.
Okay.
Yes.
Hello, good morning to all. I present my paper Detect Insider Threat from Employee Communication using Natural Language Processing. Myself, Savramnim Jay, I am the research scholar of DMI HER from India. These are my contents. Just a introduction. So rapid growth of digital communication in organization has the increased cybersecurity risk. Insider threat are one of the most dangerous threat due to authorized access. Insider, just like employee or contractor, can misuse sensitive data internally or intentionally or unintentionally. Traditional security system fail to detect behavior anonymous. Need for advanced intelligence system for early detection or any threat. Natural language processing enable analysis of employee communication pattern just like mail, charts, and report. Existing approach is there. So first one is traditional security system. There are rule-based detection, log monitoring, and access control system. Second point is machine learning approaches. There are decision tree and support vector machine SVM. Third point is behavior analysis, means network analysis and user activity monitoring. So problem is cannot detect the threats behavior changes. Second, lack of real-time insider threat detection. Poor handling of unstructured text data and limited explainability of models. These three are my objectives for my paper. So first one is develop an NLP based framework for insider threat detection. Natural language processing I use in my paper. Second, analyze employee communication for behavior patterns. And third one, compare multiple machine learning models just like random forest, SVM, and LSTM. my proposed methodology are: first steps, I collect the data from CERT inside a thread dataset and some simulated logs, means artificially generated dataset. Second step is pre-processing. So first I use tokenization system or technique where all the data are break in words. Then some stop words removal, unnecessary words I remove. Then using root word or base word, using lemmatization techniques for that, and name entity recognition NER for the we can say distribute the all the words. Third step, there is a feature extraction. So I use TF IDF, highlights important words, ignore common words. So for the highlighting some threading words, some negative words, some odd words, for I use TF IDF. Next, word to vector or BERT. Next point, semantic sentiment analysis. So somewhere there is a emotions is there, no words, no text. So that time I use semantic analysis and topic modeling, LDA. For model development, I use random forest, SVM, and LSTM, long short-term memory. So it is a RNN type. And fifth step is evaluation, where I calculate accuracy, precision, recall, F1 score, and SHARP for explainability. My dataset consists 12,000 communication samples, where 60 is normal and 40% is thread. And key finding are, so I use SVM and random forest, but I get LSTM achieve best performance with accuracy 92.6%, precision 91.3%, and recall 90.7%. So as compared to random forest and support vector machine, SVM perform lower as compared to LSTM. My importance insights is negative sentiment strongly linked to thread. Where is a negative word or where is a negative line? So it's called, I said it is a thread, as a thread. And second is passive aggressive language indicate risk. These are my performance comparison, where you can see random forest accuracy is 89.3%, where SVM 80.54, and LSTM is higher, accuracy 92.6, and precision recall same. So my conclusion of my paper: natural language processing based approach effectively detect insider threats. SLTM model provides high accuracy and reliability than NLP and SVM. Third point, behavior feature just like sentiments, tones, communication patterns are critical to analyze or identify. SHAP, SHARP, improve model transparency and trust. And last conclusion, system is scalable and suitable for real world cybersecurity application. These are my future work. In future, if anyone want to work on it, so the point is deployment of real-time monitoring system. Second is integration with enterprise security tools. And third one, multi-model analysis, text behavior or logs also. These are my reference. Thank you.
Yes, Sapnacha ma'am, any questions for him? Najira ma'am, any questions for sir?
Yes, ma'am. Thank you so much. First of all, congratulations, presenter. Thank you for the clear presentation. This is an important topic, especially today, where most organizational communication happens online. I have only one question, sir. How does your system handle unclear or indirect message that may not clearly indicate a threat?
So thank you. First of all, thank you, ma'am. So I use NLP. So using some words or any odd word, negative word, any harsh word, using or analysis that word in our lines or paragraph. So if their word it occur, we provide some dictionary of hard word or negative words. If there is a match with in that sentence, so we can say it is a threading words or it is a misbehavior words.
All right. I think that's all, sir. Thank you so much for sharing your word. I'm
Okay,
all good, ma'am. Thank you.
thank you.
Yes, thank you so much, sir.
You can start with the next. So nice presentation and a clear cut thing. Only one question is there. 60/40, you have taken the data set partition, isn't it? Okay.
Sorry, ma'am, your voice is not able to hear.
Swapnaja ma'am, your voice is very low. All right, thank you, sir, for your presentation.
Thank you, ma'am. Thank you so much.
Next, I would like to call Maria Jihan Sangil to present her study on privacy preserving synthetic data generation using natural language processing and Laplace mechanism.
Thank you. I will share my screen first. Screens, there we go. Can you see my screen?
Yes, ma'am.
All right, thank you very much. So, good morning. And I'm Frey Sangil. On behalf of my team, I'm presenting our study on privacy preserving synthetic data generation using natural language processing and the Laplace mechanism. So I'd like to acknowledge my co-authors, Engineer J.R. Barajas from Bicol University and Mr. Rabni Klim from Tech Labs. So first, the Open Data Handbook defines open data as data that can be used, reused, redistributed freely and publicly with no limitations except for attribution and share alike. And open data is often associated with positive objectives like fostering innovation, economic growth, democratic participation, and public sector efficiency. However, there are also major concerns around open data, and one of them is privacy concerns and the lack of individual control over their personal data. Now, in 2018, we started the Cloud City project. So this is a multi-stakeholder project that uses ICT tools to collect, analyze, and incorporate citizen feedback data in government decision-making. And in 2022 until present, we partnered with the Philippine National Police Regional Office 5 in the conduct of their semestral community engagement survey. And in exchange, so we're processing their survey data for free, collecting and processing for free in exchange that all the results and reports and methods are published publicly in an open portal, cloudcity.tech. And the data and results is shared with our academe partners for processing, analysis, and validation. Now, in our partnership, we encountered two major challenges. The first one is eliciting truthful and objective feedback from respondents because initially they were not anonymous. So we made it anonymous. Second, since we work a lot with collaborators with various universities, sharing data sets can still de-anonymize respondents, even though we don't collect names, because we have open-ended feedback fields like these. So sometimes respondents would say, hi, my name is Frey and I hate this service, for example. So they de-anonymize themselves and it's still a privacy risk. So differential privacy, this is an example of a privacy enhancing technique that uses rigorous mathematical frameworks to guarantee the privacy of individuals with information within a dataset. Now, a core DP technique, this is what we used here, is the Laplace mechanism, this one, which adds controlled noise sampled from the Laplace distribution to the database query before it is returned to the user. So it's like shuffling the data set a bit. Now, this one, the epsilon value, the privacy loss budget, this helps us calibrate the trade-off between privacy loss and utility of a data set. So the higher the privacy loss budget, the less the secure the query is, or the less private. This sounds promising. However, a major challenge in adopting differential privacy in practice is making it practically usable, because sometimes it can be difficult to understand, especially for small data processors or small organizations with little to no skills, technical skills capacity to perform these kinds of obfuscation. Now, the objective of this study explores the use of a differentially private synthetic dataset generation process from our raw survey dataset to enhance the respondent privacy, especially when we share it across multiple partners or researchers from different institutions. And we also want to be able to be transparent with the mechanism that we use to enhance their privacy. Now, our data source for this is the actual data, survey data we collected in partnership with the Philippine National Police Region 5, but this is completely anonymized. This is the data from 2025 from 2 survey batches, and we have a total of 9,780 individual responses. And then we have 23 variables and fields here. Now, this is the processing pipeline. So first, we identify the privacy risk level of variables, because not all variables are risky. So just here, we identify the text feedback, the open-ended feedback data to be the highest risk. And then we code them using latent dirichlet allocation, LDA topic modeling, and sentiment analysis. Now, we split them into blocks, wherein each block has correlated values and variables, and we apply the Laplace mechanism, or we add the Laplace noise to each block, and then we query and a synthetic data set, and we recombine it and we publish that with metadata and the Laplace parameter that we used. So we compared that with the raw, with the original and the synthetic data, and then we validated it with the stakeholder for calibrate the Laplace value. Now here, for example, this is the risky field. So we replace the plain text with a topic model, the closest topic model. Again, it's with LDA, k equals 10. And then a corresponding sentiment was calculated using a lexicon-based model. So we approximated if it's positive, negative, or neutral. And then once we have that coded data set, we split it into blocks, correlated blocks. This is determined by the analysis requirement because, for example, the police wanted to know the best performing police station per province. So the province must absolutely preserve its correlation with the ratings. So once we've identified this, we came up with 4 blocks. And then once we have that, we now add Laplace noise to the database, to the query. So we have a total privacy loss budget of 1. And since we have 4 queries, we divided it into 4. So this is heuristically determined alongside with our partner. So there, now we came up with 9780 row, very similar to our original dataset. Now, comparing the synthetic dataset with the original dataset, we can see that the total variation and maximum shift for all variables remain below 0.2, which is with most variables exhibiting substantially lower distortion, which is practically acceptable, at least for our partners. Now, comparison of means across the datasets show that mean shifts for all ordinal variables are less than 0.25. Showing that the combined effects of the NLP-based coding and the differential privacy noise did not materially alter the central tendencies. So the shift is negligible for practical purposes. And then finally, when we looked at the correlation of the ordinal variables in the synthetic dataset, we can see that it closely mirrors the correlations of the raw data set. So the blockwise application of the Laplace noise successfully retained intervariable relationship, which is very crucial to the policy analysis. And so to conclude, a differentially private synthetic data generation pipeline combining NLP and the Laplace noise can substantially enhance data subject privacy while preserving the analytical utility of a real-world public sector dataset. The empirical results illustrated that the essential remain intact in this case, and that future applications may further refine their privacy budgets and validate downstream downstream analytical performance. But the result of this work has already showed evidence that responsible data sharing and robust privacy protection could be achieved in tandem. And then for small organizations who might want to apply this study, by the way, used free and open source tools, so no cost, making this pipeline a low-cost model for differential privacy deployment. So public sector agencies, civic tech developers, and research partners can be encouraged to adopt privacy-preserving synthetic data sets as a viable alternative to raw data sharing, particularly in contexts with uneven digital literacy and limited data control. And lastly, we really recommend future research to examine policy frameworks governing the use of PETs, particularly differential privacy, and first assess their alignments with existing data protection laws and regulatory environments in the country. Sadly, there remains limited conceptual and policy articulation on the application of differential privacy in developing contexts, sadly, like the Philippines, which highlights the need for studies that explore how tailored policy approaches can support its effective and responsible adoption. So thank you very much. If you have questions, sir, ma'am.
Sapnaja ma'am, any questions?
Yeah. So it is you are talking mostly about the open source tool and their using natural language processing. Can you just tell me 1 or 2 points? What are the constraints or the tools? Okay, mainly you found when you are working with this particular type of the project.
Yes, ma'am.
Major
Thank you.
constraints which are common on most of the open sources on the data set.
Yes, ma'am. Thank you very much. Yes, absolutely. So for this, we used R, and there is a DP package. However, in this case, we had to create the Laplace mechanism in our case because we're partnered with the police. So we had to do the tool, the actual calculation ourselves. So we created that function in R. However, there is differential privacy package, which is very similar. It's called D package, ma'am. You can access it for free.
Okay. Thank you.
Yes, ma'am. Thank you, ma'am.
Najira ma'am, any questions?
Yes, ma'am. Thank you. Hi, ma'am. Congratulations po. Thank you for your presentation. This is a timely study, especially in addressing the growing need for data privacy in machine learning and NLP applications. I have only one question. How does your approach ensure a good balance between privacy protection and data usefulness?
Yes, ma'am. Thank you very much. Actually, right now, we are our core. We are anchored on the PLB value. So industry standard, at least based on global standards, it's 1 for it to be secure. Mathematically. However, just to be sure, and since we are working with the police, we make sure that for every data that we publish, we first course it through them application. So we have a total of 3 stakeholder validation before we publish it. So first with the university partner, second is with a civil society organization. So this can be People's Council, for example, and then the partner government agency, in this case, the police. So once we get all the agreement that, okay, this is okay, good to go, the clearance, then that's the only time that we publish the synthetic data set, both for technical and for legal protection as well, ma'am.
Yes, ma'am. Thank you so much, ma'am, for your clear answer. I think that's all, ma'am, for me. Thank you so much and congratulations.
Thank you very much for the opportunity.
Yes, thank you so much. Now, next, I would like to call Pasulamagiri Janvi to present her study on Signura, signature verification via Siamese transformer with synth pressure map augmentation.
Yes, ma'am. I am present here. Can I share the screen, ma'am?
Yes, ma'am.
Is it visible, ma'am?
Yes, ma'am. Please start.
Okay. Good morning, all. My name is Daphnavi, and I am from RGM CET Nandyal. Today, I'll be presenting our work titled Signura, Signature Verification via Siamese Transformer with Synth Pressure Map Augmentation. Coming to the abstract, handwritten Handwritten signature verification is widely used in banking, legal, and financial security systems. To address this, we proposed a hybrid model combining Siamese network and transformer encoders with synthetic pressure map augmentation. This improves especially in few shot scenarios where a few genuine samples are available. Our problem statement is that these handwritten signatures are widely used for identity verification in banks, legal, and financial systems. Genuine signatures may vary each time when they are written. So, to capture existing systems, fail to capture global patterns and dynamic characters like pressure map, and strokes, etc. To overcome this, we have created our problem, our system, hybrid system. Coming to the literature survey, existing systems used Siamese transformer models for better performance. Now, at 2016, they have used handcrafted features and traditional classifiers. The latest CNN-based models are improved and extracted from the large data sets. Here we are using both the Siamese transformer plus in a few shot learning with the synthetic pressure map augmentation. Coming to the proposed methodology, we proposed a hybrid deep learning model for the handwritten signature verification using scanned signature images. It combines Siamese networks for similarity learning and transformer encoders for global context understanding. A key innovation is that the synthetic pressure map generation, which adds dynamic like information to static signatures. Model is trained using triplet loss to differentiate between genuine and forged signatures. Finally, a similarity score are used for classification. Next, coming to the architecture, here the system takes two signature images as input. Each input is pre-processed, that is grayscaled, binarized, and normalized, and resized to particular size, that is 100 into 100 pixels. Then the transformer encode. Then these inputs are passed through CNN layers for local future extraction. Then then pass it to the transformer encoders for global strokes extraction. Then the output is converted into embedding vectors. Then the distance between the embedding vectors is calculated by using the Euclidean distance formula, whether the signature is genuine or forged. Coming to the advantages of our system works well with limited data using a few shot learning, and high accuracy captures both local and global patterns using CNN plus transformer. Pressure simulation, a synthetic pressure map simulates dynamic handwriting cues without needing any online input devices. Forgery resistance, here more effective at detecting skilled forgeries due to deep embedding comparison and attention mechanisms. Low error rates achieves reduced false acceptance rate and false rejection rates for secure systems. Coming to the challenges, here we have faced technical dataset and evaluation challenges. In technical, capturing the both local and global representations are hard for us, and handling the skilled forgery signature is typically difficult. Coming to the dataset related, only a few limited offline signature datasets are available. So we have augmented the datasets, and we have performed the training and testing of the data. Coming to the evaluation, achieving low FAR and FAR simultaneously is very difficult. We have overcome the challenge and with a high accuracy. Coming to the result, experimental result shows that our model achieves high accuracy and maintains low FAR and FRR. And compared to CNN and traditional Siamese models, our approach performs better and with the low FAR and FRR. Here are the results. This result shows the image shows that they are genuine signatures. According to the pressure map, it detects the whether it is genuine or forged by calculating the similarity distance. And this is an example for forged signature. Coming to the summary, we proposed Signura, a hybrid Siamese transformer architecture, introduced synthetic pressure map augmentation for offline signature verification. This system integrates CNN, transformer, and triplet loss. Here in triplet loss, we have anchor positive and negative. According to this, we calculate the distance between the two signatures. And I expected outperform CNN and Siamese baselines in few shot scenarios. And suitable for banking, forensic, legal, and e-government authentication system. These are the references we have used, and thank you. Any questions, ma'am?
Sapnaja ma'am, any questions?
Why you use the Euclidean distance to get signatures, all that thing?
To calculate the distance between the two signatures, ma'am. What is the similarity score between the two?
I understood, but why you selected that method only? There are so many letters, actually, methods.
We think it is the best way to calculate the
Yeah,
distance.
how you did it? How you decided that it is the best way? It is on the literature review, or it is some testing you have done for the selection of the data set, or what?
We have done testing, ma'am. Before we have used other formula, but it has shown some errors. So we have
Which
to,
formulas you used? Other formulas? Manhattan distance, and what type of the distances other you have used?
Sorry, ma'am. Can you repeat the question?
Have you used any Manhattan distances or other type of the formulas to calculate the distance?
Yes,
between
ma'am. We
two
have used some other formula, but I am not able to remember the formula, ma'am, right now.
Okay, it's all right. Because I want to ask you with how many other distance formula you have used it. Okay.
Okay.
Yes.
We have used
Because it is
Manhattan
very
distance.
old. Actually, so many other methods are also there. It is quite old method. Okay, it's all right. Huh?
Okay.
Najira ma'am, any questions?
Yes, ma'am. Thank you. Yeah, first of all, congratulations, ma'am, for your presentation. This is actually a clear and interesting approach when it comes to improving the signature verification. Using the combination of Siamese networks and yeah, the transformer models. I have only one question.
Okay, ma'am.
What makes your augmentation method more effective compared to common data augmentation techniques?
As we have used a few shot scenario, we require only few data sets we will not get the signature data sets from many persons. We'll get only 5 to 10 signature samples. We cannot perform the testing or training of the model with only 5 to 10 signatures. So we have augmented the data which creates more accuracy for the model.
Yes. Thank you so much, ma'am, for answering the question. So I think that's all for me. Thank you for sharing your word.
Thank you, ma'am.
Yes, thank you, ma'am. Now, next, I would like to call Kirin Nopanitaya to present his study on the generative AI usage and ethical guidelines in graduate education of Payap University.
Okay, thank you very much. Okay, can you hear me?
Yes, sir.
Okay, I will share about the presentation. Okay. Okay. Good morning again, everyone. Today, I would like to present about my research title paper is a generative AI usage and ethical guidelines in graduate education of Payap University. Okay. The presentation outlines include introduction, literature review, material methods, result discussion, conclusion, limitation, and reference. Introduction for my research for generative artificial intelligence has rapidly transformed higher education in Thailand, and particularly at the postgraduate level. where students are expected to strengthen their analytical thinking, academic writing, research planning, and problem solving. And existing evidence indicate that Gen AI exert a dual effect. It can augment learning and research productivity through the content generation, data analysis, and problem solving support. And many students use Gen AI to save time and improve the quality of their work. Okay, and it usually clear policy communication remain limited as resulting in a shadow pedagogy, insufficient oversight. And next is for educational institution and instructor. The primary objective is to adapt assessment methodology and instructional design to promote responsible use, minimize valuation of inequality, and reinforce unique human skills such as a high-order critical thinking and reflect ability. And effective policy framework should need acceptable usage, disclosure, and citation procedure, transparency, and method for verifying originally. And accordingly, this proposal investigates the use of Gen AI within the graduate program at Payap University, covering behavior experience, ethical awareness, learning impact, and integrity challenge. Okay, and this study aimed to analyze the current practice and the future trend in the use of Gen AI by the graduate student in independent study, thesis, and dissertation, and also seek to evaluate student competency and readiness to use Gen AI effectively and ethically. And additionally, the study explored the advantage, limitation, and academic impact of Gen AI in graduate education and consider relevant ethical framework to promote responsible use. And finally, to develop practical guideline and policy strategy for Payap University to integrate generative AI into graduate teaching, learning, and research. Okay, in literature review, the generative AI, particularly in large language model, is increasing use as a graduate level academic support tool for tasks such as literature, search, summary, outline, academic writing, and language editing. And however, unclear boundary between acceptable assistance and threat to originality, along with reluctance to disclose AI usage, highlight the need for clear guidelines for high-level academic. And at the institution level, universities are responding with authentic assessment and Gen AI literacy training and effort to promote equitable access. Nonetheless, policy gaps persist, particularly regarding privacy and data protection. And this situation will reveal that Gen AI is graduate research is a systematic issue connected to academic culture, quality assurance, and evaluation intensive. And because Gen AI can quickly generate possible academic text, the main challenge is not just basic usage, but also the skills learner to need to access quality, verify accuracy, and take responsibility for output. And consistent with this, a systematic review on Gen AI and academic integrity urge that primary risk come less from the technology itself and more from weak self-regulation and limit awareness of model limitation. And recent research further refined AI competency as a combination of conceptual knowledge, critical and ethical judgment. And ethical oversight of Gen AI is higher education has evolved from bans to regulate use defining scope, requiring risk growth and redesign assessment to evaluate human ability. Okay, in UK, university often develop policy balancing fraud prevention and preparing students for an AI-driven workforce, and with other accountable for accuracy despite risk of error and fabricate content. And this one is the conceptual framework for our study. It includes of generative usage in curiosity, AI competency, academic integrity, ethical issue, and institution guideline. And this one is to communicate and to integrate by using some instrument like mixed method from survey and interview to be analyze research outcome to deploy the ethical guideline and policy recommendation for use Gen AI. Research scope is used for graduate students at Payap University. and examine how GenAI is applied in independent research, thesis, and dissertation. And population is from graduate students at Payap UC, enroll both master and doctoral program across diverse fields. And these students are essentially generate academic work that demand advanced analytical skill, scholarly writing, and systematic research technique. And the sample, we use the concept from Chris and Morgan sampling method from 1970 for quantitative research. But for qualitative research, purposive sampling were employed by use a certified sampling. Select students with experience with generative AI in their study and research to gather insight in real-world experience and ethical perspective. For the survey questionnaire, we'll collect by using and design by align with Bloom taxonomy, from memorization to understanding to evaluation, creation, and appropriate to graduate student behavior. The survey include multiple choice, 5-level Likert, and open-end question. And this one is the structure of a survey questionnaire by divided by section like demographic, use of expectation, competency level, benefit of Gen AI, ethical concern, and institution practice for ethical integration. For the method is an interview focus group protocol, and the qualitative data collection will use a structured questionnaire, and questionnaire was shared with predefined group of graduate students at Payap University, and it was designed in online format to make access easier and reduce time constraint and boost response rate. Before collecting the actual data, the clarity of question and the appropriate of the language were reviewed to ensure the questionnaire accurately access Gen AI usage. The data collected were systematically recorded and stored at later statistically analysis. For the qualitative data collection, using in-depth interview and focus group discussion were the main method used. Okay, and the interview and the focus group process aim to explore perspective, reason for using or not use Gen AI, ethical understanding and awareness of academic integrity by statistical analysis of survey data, by using the quantitative data, by use descriptive statistics to outline general and suitable interferential statistics like mean comparison or correlation analysis may have been employed to explore different and relationship between variables based on research goal. And using the thematic analysis and thematic to coding the employee 10 wording for each of interviewer by using qualitative data. By ethical consideration, reducing to adhere to ethical principle by human research, emphasizing volunteer participation, privacy, and protection of personal data. Before data collection, participant was briefed in the research goal, and all data was shared only through statistical summaries or aggregation. And current station, but the result is the current situation and future trend in the generative UI. In Payap University, current application often include literature review and helping to comply and improve academic language, generating research idea, and sometimes supporting data analysis. And the study also suggests a high likelihood that the use of Gen AI will grow in the future. And the level of competency in Gen AI among graduate students, it showed that graduate students show a moderate to fairly high overall skill level in using Gen AI, especially in digital skill communication and leverage AI tool for academic tasks. Okay, and this finding highlight a gap between technical ability and critical and ethical understanding. Addressing this gap is essential for further progress. In part of advantage of using Gen AI in graduate, most students see Gen AI as a helpful tool for improving the efficiency of learning and research. It actually save time on academic task support, and limitation and education for using this one will concern include inappropriate plagiarism or citation and overall reliance on AI, which may harm to development of critical thinking skill. In
Excuse me, sir. I request you to conclude your presentation.
Oh, okay, yeah. And this one is show about the conclusion. The paper of Gen AI for my paper influence graduate study of Punjab University, considering the rising impact on AI, particularly large language model LLM on learning, academic writing, research, and show about present challenge related to accuracy, transparency, and ethics, and finding reflect graduate student of Mapayap using Gen AI and show about trend of increasing frequency and complexity. And the last one you show about policy and economic educational management implication. We show highlight to keep Payam University to shift from a technical-based control approach development to integrate student competency development process oriented and using ensure Gen AI serve as a tool to ethically and sustainably enhance quality of education. For the limitation is have some single institution because it show just only Payam University. So it may be to propose many information from other university to say about the other aspect. Okay. Here is the reference. Okay, thank you very much.
Swapnilja ma'am, any questions?
Yes, ma'am. I have one question. You were talking about the in the sampling, okay? Sampling of the data. Am I audible? Am I audible?
Yes, ma'am.
Yeah.
Okay. In the sampling of the data, you are using the insights, isn't it?
Actually, I use the sampling for our technique using as
Insights. You say you worked on the insights there. I just
okay.
want to ask which parameters you have used for the insights. This is the first question.
Yeah, the first question.
And the second thing is you are talking about into the ethical issues, the privacy protection, okay, of the where from you have from the of the resources from where you have collected the data, isn't it?
Yeah,
Yeah.
actually in Payap University at first, if you wanted to decide about the question that may be an impact about some privacy information, we should be complied by the organization that how can I
You
say?
did it manually or any technique AI generative tool you have used?
Yeah. Uh, um, actually I use I use I use
Yes.
But you mean about the privacy concern in the
Yeah,
question?
about the privacy concern. Have
Uh,
you used any AI tool or you
okay,
did it manually?
okay. In Thailand, we call IRB. IRB is to uh, e-
Oh,
every research title that involve with human, like to ask them to make them not feel uncomfortable in each issue. We used to comply by IRB, and IRB will see about the questionnaire and in part of interview and in deep interview. If it can pass, IRB will give me to
so is it a open source or it is used into the Thailand only?
pardon, sorry, ma'am.
Is it a open source or it is used into the Thailand only?
Right.
Okay, thank you very much. Very
Thank
nice
you very much, ma'am.
presentation.
Sorry
Have a good
for
day.
my unclear answer. Sorry.
Yeah, thank you very much.
Najira ma'am, any questions?
Yes, ma'am. Thank you. First of all, congratulations, sir. Thank you so much for your presentation. This study is actually very timely, especially as generative AI becoming widely used in graduate education. I have only one question, sir. How does the university plan to ensure that students and faculty follow these AI guidelines?
Oh, okay. Thank you for the question, ma'am. Actually, we found that the student right now have a high digital skill, so they might be admit to uh, limitation in evaluation by the AI accuracy. So that's why our Payap University have plan to build about some ethical issue concern, like some manual for the student at first. For example, when he start to apply for a master degree or doctoral, they usually use this tool in maybe in literature reviews or dissertation tool, or maybe tricky in have some fake citation, something like that. So at first, our lecturer, especially for every professor, wanted to learn about the step about how to student use the AI creativity, and remind them to use not plagiarism, and uh, to identify which one is wrong, which one is true policy, something like that.
Yes. Yes, yes, sir. Thank you so much, sir, for the clear answer. So I think that's all from me. Thank you, ma'am.
Thank you very much, Krab.
Yes, thank you. Now, lastly, I would like to ask Asmit Patil to present his study on an
Yes, ma'am.
adversarial evaluation of stealthy insider attacks and UEBA-based defensive detection in enterprise environments.
Yes, ma'am.
And I request you, sir, to please make your presentation concise since we have a time constraint.
Okay, ma'am. Is the screen visible, ma'am?
Yes, sir.
Okay. So, good morning, everyone. Myself Asmit Patel, and today I am presenting our research paper titled Adversarial Evaluation of Stealthy Insider Attacks and UABA based detection. This paper focuses on one of the most difficult cybersecurity challenges, which is detecting insider threats, especially when attackers use legitimate credentials and trusted access. Our work studies how such stealthy insider attacks can be simulated and how they can be detected using UABA behavioral analytics. Uh, in the abstract, this paper addresses the problem of insider threats where attackers operate from within the organization using valid credentials. Traditional detection methods often fail because these attacks do not involve obvious policy violations or known malware signatures. To study this, we used an adversarial red-blue framework. The red team simulates stealthy insider behavior. The blue team uses UEBA or user and entity behavior analytics for detection. Our main observation is that insider threats are better detected through the correlation of weak behavioral signals over time, rather than by looking for a single suspicious event. Then, motivation for the paper. The motivation behind this work is that insider threats are among the hardest cyber attacks to detect. This is because insiders already have valid credentials, trusted access, and familiarity with internal systems. Then, traditional security tools are mainly designed for external intrusions, malware, and signature-based detection, but insider attacks are usually slow, subtle, and appear legitimate. So there is a clear need for systems that can identify behavioral deviations over time, which is why we focused on UABA and adversarial evaluation. Introduction. In insider threat scenarios, the attacker is not an unknown external hacker, but a trusted internal user. This makes detection difficult because insiders use valid credentials and operate inside trusted environments. Traditional systems like signature-based detection and rule-based detection are not effective enough in such cases. This is where UEBA becomes useful. UEBA helps detect anomalies in user behavior, but to test its effectiveness properly, we need a realistic adversarial evaluation, which is the main focus of our paper. Then literature survey. In the literature survey, we study four major approaches. First is rule-based approach. These work based on predefined rules and policies. These are useful for known violations, but they fail when insiders operate within their allowed permissions. Then second is statistical methods. These identify deviations from normal behavior. However, they are often weak against gradual or stealthy changes. Third, machine learning and UEBA. These are more advanced and can model behavioral patterns, but they face challenges such as data imbalance because real insider attacks are rare, and concept drift where user behavior changes over time. Fourth is adversarial evaluation. Most existing adversarial studies focus on malware or network attacks. There is limited work specially focused on insider threats. That gap motivated our research. Then we have existing system. The existing system mainly relies on antivirus solutions and rule-based EDR systems. These tools are effective only for known threats. Their major limitations are they depend on explicit violations, they fail when legitimate access is misused, and they cannot properly detect stealthy insider behaviors. Then we have objectives of a work. First, to design a realistic red team model for insider attacks. Then second, to develop a UEPA-based detection pipeline. Third, to map attacker behaviors to specific detection signals. And fourth, to evaluate the system based on detection accuracy, latency, and false positives. Then methodology. Our methodology is based on adversarial symmetry, where both the attacker and defender are modeled in a realistic way. In the red team, we represent the insider attack. In the blue team, we represent the defending detection system. There are 3 points. Legitimacy. The attacker only uses valid credentials, not stolen or fake access. Then second is stealth. The actions are performed in a low frequency and gradual manner. Third is observability. The blue team only observes metadata level activity, not deep content inspection. Then we have proposed system of red team. In this, first, it is simulates stealthy insider attacks. Then second, the insider collects information using native system tools. Third, privilege misuse. The insider misuses already available permissions without privilege escalation. Then fourth is persistent scheduled tasks, normal workflows. Fifth is covert communication, slow fragmented data transfer. Sixth is temporal evasion, randomized and delayed actions. Then we have proposed system of blue team, that is UEBA. In that, first is telemetry collection. It collects metadata from endpoints and network activity. Then feature engineering, behavioral features are extracted such as time-based patterns, frequency-based patterns, and contextual activity signals. Third is baseline construction, that is user behavior modeling. Fourth is risk scoring, aggregates deviations into risk score. The key idea of the proposed system is detection comes from cumulative weak signals, not single events. Then the system architecture. This architecture consists of four major layers. Telemetry collection layer. This is the layer which collects endpoint and network metadata. Behavioral analytics layer extracts patterns and detects anomalies. Third is risk aggregation layer, combines multiple weak signals into a final risk score. Fourth is evaluation control layer, which controls attack simulation and defensive monitoring. Overall, the architecture supports both realistic red team attack simulation and blue team UEBA based detection. Then we have results and discussion. In the results, we observed an important pattern. In early attack phases, the suspicious signals were too weak to trigger detection. So in later attack phases, as multiple small deviations accumulated, the UEBA system was able to detect the attack. So the main insight is single actions may remain undetected, but multi-phase suspicious behavior becomes detectable over time. This confirms that UEBA is effective, especially for low and slow attacks and behavioral drift detection. Then we have advantages. Our proposed system has several advantages. It can detect stealthy insider threats. It works even when the attacker uses legitimate user activity. It uses behavioral correlation over time. It reduces dependence on known attack signatures, and it can provide more explainable risk-based alerts. Then we have disadvantages and limitations. Despite its strength, the system also has limitations. It depends heavily on a clean and accurate behavioral baseline. Detection may be delayed in low and slow attacks. Our current model is limited mainly to single insider scenarios. Initial deployment may produce false positives, and if attacker behavior remains closely aligned to the user's role, detection may take longer. Then in the future enhancements, we have peer group normalization that can improve baseline quality. Then dynamic risk weighting can make scoring more adaptive. Cross-user correlation can help detect collusion between insiders. Testing on real-world data sets such as CERT can strengthen evaluation, and false positive handling can be improved further. Then in the conclusion, to conclude, insider threats are difficult to detect because they often operate within trusted boundaries using legitimate access. Traditional detection systems are not sufficient in such cases. Our work shows that UAPA can detect insider threats by identifying behavioral deviation and correlating weak signals over time. A key conclusion from this paper is that insider detection is not purely event-based, but rather time-based and cumulative. Finally, adversarial evaluation is important because it allows us to test detection systems under realistic threat conditions. Thank you.
Yes, thank you. Samrija ma'am, any questions?
Yeah, you are talking about the event based. Okay, so only
Yes.
event based is not sufficient. You are talking about which type of the events you are considering.
Uh, Ma'am, events means when the attacker is from the company itself, so he can access everything from inside. So he can change
So
the
you
files of
want,
the companies or like
want to
that.
write it as a historical events or the real time events happening as a triggers.
Ma'am, both the events here.
Okay, both the events. Yeah. Thank you very much.
Nazira ma'am, any questions?
Yes, ma'am. Thank you. First of all, congratulations, sir. Thank you for your presentation. I appreciate that you look at both the attacker and the defense side. I have one question. What are the common behaviors of insider attacks that are easy or hard for UABA to detect?
Can you repeat the question, ma'am?
Yes, sir. What are the common behaviors of insider attacks that are easy or hard for UABA to detect?
Um, mm, um, Actually, the UABA can easily detect insider attacks when the attacks shows clear behavioral detection from the normal pattern, means such as unusual login times or abnormal file access. Then, if someone accesses a sudden data or someone sudden data transfer or use unfamiliar systems.
Yes. So thank you so much, sir. So I think that's all from me, ma'am.
Yes, thank you so much. Okay, so now with this, we conclude our session. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters will be getting their digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. Hence, I kindly request cooperation with the team of ICTIS 2026.
Thank you very much for inviting us as a session chair. It's a really wonderful interaction with the participants. Really good study is going on into the smart cities and the smart AI, ML, and especially deep learning and other things. Thank you very much, participants, for your nice presentation and sharing your ideas with us. Thank you very much, ma'am.
Yes,
Can I
thank you so
leave?
much, ma'am. I've shared a token of appreciation on behalf of the team.
Okay, thank you very much. So can I leave, ma'am? I have my
Yes, ma'am.
practicals. Okay, thank you.
And thank you, Najira Umpal ma'am, for chairing this session. I'm sharing the token of appreciation on behalf of ICTIS, and I request you to share a few words for the presenters.
Yes, ma'am. Thank you so much. Once again, thank you to all the presenters for your excellent presentation. As a session chair, I really find the discussion very engaging and intellectually stimulating. I would like to commend all the authors here, the presenters, the researchers for the clarity in presentation. At this point, I would like to extend as well my gratitude to the conference organizer, program committee, to our very own moderator, Ma'am Dimahi Patel, and to everyone behind the scenes who worked to make this event possible. So once again, congratulations to all the presenters for your outstanding work. So I think that's all from me. Thank you po.
Yes, thank you so much, ma'am. Now I kindly request everyone to please turn on your cameras for a quick snapshot of this virtual conference. Yes, thank you, everyone. Please have a great day ahead.
All right. Thank you. Bye-bye.
Thank
Bye-bye.
you.
Thank you, all of you.
Thank you so much.
Thank you so much.